Okay, so I'm just going to do a full demo of the socket controller. So we're going to start with our device here, and we are going to hold down the Wi-Fi button, that button there, while we plug in power. So let's go ahead and do that. So we've got our power. And that should work. Okay, so now we've booted into AP mode. So now we'll come across to the computer. I'm just going to start a screen capture so I can potentially sync them up. Cool. So now we'll connect directly to the device, and then we'll go to the IP address for the device like this. So now we're connected directly to the device. So now we'll change the settings. So we'll come across to Wi-Fi and we'll change it to station. We'll select a station to connect our Wi-Fi, to connect the device to. So we'll choose this one, already selected it, put in our key, close and save, and that will boot us back into station mode. So I can either do that through the web interface, just click save, or I can just reboot and it will automatically come back into station mode. So, because I haven't actually configured it to access point mode. So now we're in station mode on the device, and we're on the same LAN. So we're both on the same wireless network. So I'll come across to this tool here, find.socket controller, and now we have our local IP address and the host name, so we can connect to the device on our local network. So now we are connected. Okay, now we're going to control some outlets. So we'll come across here. Right, so I'm going to connect a kettle into outlet A. So now we can see we've got outlet A plugged in to a kettle. So now let's demo that. We want to see what's going on. So in our computer, let's disable these programs. Humidity disabled. Okay, so we will measure our voltage, enable that, save, power, enable, save. So now we have our voltage. We're in Australia, so our voltage is coming in at 240, which is expected. The device handles universal voltage. Whatever comes through is fine. So we've got 240 coming through, and our power is 10.7 watts. Great number. Alright, so now let's turn on that kettle on output A, excuse me. Manual, output A, and save. Okay, what did I mess up there? Enable, output A, boom. Okay, so now we are drawing. Let's turn this kettle on. Okay, so we'll see that we're turn it back off. So we saw that we're actually not drawing power. So output A is bypassing the power sensor. So now we can do output B, which does have the power sensor. So by default, output A bypasses the power sensor, so that allows having two different devices only measuring one power, which can be useful for different situations. So in this situation, we'll go across again, and this time we'll turn output B on, and we'll see what power the kettle is drawing. Cool. So we're drawing 13 watts. This kettle is output A. Okay, output B and active. And then now we're drawing 2 kilowatts. So I don't want to hear that kettle again. Turn that back off. So there's our 2 outputs. Now we're going to plug in a sensor. Just going to open this up. Okay, now we have our sensor plugged in. So we'll just come across to our settings, and we can see that we've got our power sensor and our new 2 sensors. So we've got our light, temperature, humidity. Okay, so let's demonstrate those sensors. So we'll turn on our temperature sensor, humidity, light, back on the dashboard, temperature, that's not correct. So we want temperature to be set to temperature, save. Okay, and now because it is below the threshold, it has actually turned that on. Let's come across here. So let's say if it goes less than 10, I'm just going to turn this to monitor mode, so it'll be monitor only for temperature. So we're monitoring temperature. All of these different sensors are all being monitored simultaneously. Cool. So now we can see all of those different sensors are active at the same time. Okay, so now let's do a sensor-based trigger controlling an outlet. So we just saw that, but we can do it again. So let's use the light level to control the output. So we can see the light is hovering around 50. So let's control the output based on light level. So if the light level, we'll turn this into an active program. Controlling output B using the light. If the light goes less than 15, we'll turn on the output, and then above 17 it'll turn back off. So we'll come back across here. Okay, so now this is all live right now. So if I get the light level to come below 15, it'll activate output B, which is our kettle. So let's demonstrate that. Here we go. I'm going to cover up the light sensor with my finger, and now we see we are drawing 2 kilowatts, and back off again. So that is a demonstration of sensor-based triggers controlling an outlet. Now let's interact with the dashboard. So with our dashboard, all active programs will appear. There's only 2 active programs for outputs, which is A and B, and the active program for an output will be the one with the highest priority, and that is a descending list. So as we see here, descending priority, so temp, so whichever has the highest priority for each output will be active. In this case, output B is active, and all the others have null output, so they're just monitoring. Okay, we can adjust the widgets on the dashboard. So let's say we want to adjust this one, so we'll click on the options. So we've got 3 different sections, and that's shows us how we can configure the dial there. So if I want to make that like 15 to 30 or whatever, now that has a wider range on that gauge there. So that's the widgets on the dashboard. Okay, now let's show logging. So we'll go across to our settings. For logging, we have temperature and humidity being logged on the active sensor. And so if we go to graphing, we can see every 6 minutes it'll log a data point based on, it'll average every 6 seconds over every 6 minutes. So we can see those for today. Wait, no, that's a couple of days ago, so it hasn't reached a logging point yet for today. So let's go back, and if we go back to Sunday the 3rd of May, we can see we've got logging from 9:30 at night through to 8 AM. If I isolate that for temperature, we can see all these data points every 6 minutes. So 9:36, 9:42, 9:48, right? And so every 6 minutes basically. So that's our logging. As these logs start to fill up the storage, it'll start trimming the oldest logs by deleting the oldest logs. Further, if we go to settings here, if I want to change this to include light, we can update that and save that. And then what we'll see is that the previous log data for that day has a new name, file extension. So now it has .old.log. So we have one data point from today which has those, and then all further logging will have those new settings in the logging. Anything else? I think that's pretty much it. Yeah. So we can do complex things as well. So let's say I want to turn output A. So I'll turn power into a program which controls an output. So we'll control output A, and we'll turn that on if the power goes less than, let's say, 1800 watts. So now if the power goes below 1800 for output A, it will turn the output on. So now we see power is on because it's less than 1800 watts. And output B is still configured to the light. So what we can do is we can see this in action. Right. So if you understand those two different, let's make this simpler. So I'll turn all these off. Temperature is off. Voltage is off. Light is off. Okay, so power, humidity is off. And we want to turn on the kettle based on, so each time I update the programs, it will refresh the whole program priority, which is why it's turning off for a second. So now power and light. Right. Where is our light program? Okay, so light programs, light will be output B, enabled. Great, so now we have two active programs. Now, if light goes less than that value we set, it'll turn on output B, and then when the power goes less than 1800, it'll turn that off, as we can see here. So let's demonstrate that. I'll cover the light sensor with my finger, and now we see those two different programs toggling like that. So that shows the independence of the programs, I guess, and how they can be programmed. So yeah, hopefully that covers all the features and shows how it is operational, and it's a fully functioning prototype, basically ready to go to manufacturing. Obviously development is ongoing. The next parts of development will be whatever people want, but basically it is a fully standalone autonomous socket outlet controller. It's ready to roll, and development will be ongoing based on user needs, including implementing Matter for cloud-based interaction and that kind of thing. So yeah, that's about it. Peace.